All right, now we're going to keep going with linear functions and our work with standard form, and we'll be looking at a challenge and a real-world connection. I encourage you to try both of these on your own, pause the video, and then check back in and see how you did as you follow along. So our challenge here is to determine the standard form linear equation for the line that goes through those 2 points. And this is one of the drawbacks of standard form. It's hard to get the equation from a couple random points on the line. So we're going to go ahead and get our slope first, and then let's use point slope form, I guess. That's probably easiest without needing to find b, and then we'll convert that into standard form. So I think what you're seeing is we're going to get our equation in point slope form first, and then turn it into standard form. Okay, and that just demonstrates how maybe a little bit awkward standard form is if you're just being given a couple points. So let's go ahead and do it. We have our slope is going to be the difference of our y values divided by the difference of our x values. And let's simplify that down. That turns into an 8 over -6, which simplifies into a -4/3. Okay, so there's our slope, so that's good. Let's go ahead and write out our point slope form. Y minus y1 is m times x minus x1, and we can fill in. And I'm going to use this point for my x1 and y1. So we have, let's see, y minus 5 equals our slope, -4/3 times x minus -2. So y minus 5 equals -4/3 times x plus 2. So if we'd been asked for point slope form, we'd be done, but we were asked for standard form, so we have some more work to do. And what I want to do first is multiply through by 3. Let's get rid of that fraction, okay? So I am going to multiply the whole thing through by 3, and we get a 3y minus 15 equals -4 times x plus 2. Okay, quick point here, the multiplying by 3 got rid of that 3, but it didn't change anything inside the parentheses because those pieces inside the parentheses were all being multiplied by this 1/3, okay? And so we wouldn't want to multiply that stuff by 3 as well. Hope that makes sense. Let's distribute 3y minus 15 equals -4x minus 8. We could add 15 to both sides, and at the same time, let's try to be a little efficient here, let's add 4x to both sides, and I'll kind of line those up with where they'll end up. Let's see what we end up with that. So these 15s cancel and these 4x's cancel. So we have a 4x coming down with our 3y, and -8 plus 15 is 7. So there's our final outcome right there. And again, it's a little bit awkward, a lot of steps to go through to go from a couple points straight into standard form. All right, our real world connection problem is relating to, it looks like we went out for lunch. We got some hamburgers and hot dogs. So hamburgers were sold at a cost of $5 each, and hot dogs were sold at a cost of $4 each. As a group, we have $50 to spend. Write and graph a standard form linear equation that shows the possible combinations of food you could purchase. All right, and let's assuming we're trying to spend as much of our $50 as we can. Although some of the combinations might not, it might work out that we're spending $48 or something. All right, so let's define our variables. So let's let b equals burgers, and let's have that be number of burgers, not the cost of a burger. We know what the cost is. And let's let d equal number of hot dogs. So this is probably the biggest advantage of a standard form equation. You can just take a word problem like this, a scenario, and just write it in standard form. And so 5b, $5 per burger, plus $4 per hot dog is equal to 50. Okay, So easy peasy right there. We just wrote it out real quick. Okay, let's make sure we're clear on what axes we're working with. Let's have this be our B axis, our burger axis, and this be our hot dog axis. And we're going to graph it up. And remember, the way of graphing these guys is to use the intercept method. So we're going to pretend first that we got 0 burgers and we just got hot dogs. Okay, so that means that this burger term disappears. Okay, so 4D is 50, which means D is 12.5. Okay, we'll figure out what all that means in a second in terms of the real world, but let's plot it up first. So D is 12.5. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12.5 is right here. I'm going to check that. 2, 4, this is 6, 8, 10. Yeah, that looks good. And now I'll erase what I did here. Now we're going to pretend we got no hot dogs, 0 hot dogs. So we're going to cross out this hot dog term. 5B is 50, so that's easy. B is 10. Okay, so 2, 3, 4, 5, that's just 6, 8. So there's our 10 right there, and so B is 10. And we're going to connect these guys with a line, which will give us all the different combinations of burgers and hot dogs we could have gotten for our $50. Okay. Whoops, I'm going to try to be pretty precise with my line because I want to point out something from the graph here. Okay, that looks pretty good. Okay, so let's find some combinations here that look like they go through nice clean points. And my line is a little bit off, but let's still call it good here. Let's pick those couple points, and then let's think about what this point means as well. Okay, so this looks like we were at 7, 4. So 7 burgers is $35 plus 4 hot dogs is $16. So that would give us $51, and we don't have that much money, right? And I think maybe that's because, I'll see if I can blow it up in here, maybe because we actually are looking at that point is actually a little bit above the line. Okay, so our line does roughly go below that point, which it should because we don't have $51 to spend. Let's look at this point right here. We have 2 burgers and 10 hot dogs. And that gives us exactly $50. So that would be a valid point right there. Okay, so really what I'm trying to highlight is that the graph makes it a little bit challenging to really see exactly what the possible combinations are that lead to exactly $50 being spent, or maybe $48 or whatever. Okay, this point right here looks like it's about 4.5 and 7. And I just wanted to highlight that because we're not going to buy 4.5 burgers, right? We're only going to buy either 4 burgers or 5 burgers. Okay, so we have a graph that highlights the possibilities, but I think the lesson here is that we have to be really careful and accurate with our graphing, and some of the possibilities might be right on the edge and might not quite work out. Let's actually see what this gives us for dollars spent. So 4.5 times 5 plus 7 times 4. So this gives us $50.5, so $50.50, right? And so our line should be a little bit down below that because we don't have that much money to spend. All right, I'll leave it there. I think that's a good place to stop.